Hey everybody, my name is Melisha McGregor, and I'm a senior software engineer slash developer advocate at Conducto, where we make CI/CD tools using Python instead of YAML. But today I'm going to talk to you about making VR way more interesting with JavaScript and BrainJS. So at the beginning of all of my talks, especially this year, since we're virtual, I know everybody kind of zones in and out. So I like to give a quick overview of what we're going to be talking about so you know when to focus and when you can go get food or whatever. We'll start with just a background on VR, then we'll get into actually making a VR app. And making a VR app, I'm gonna attempt to show you some code that I'm not gonna change because it worked a few minutes before this talk, so I'm hopeful it still works when I try it in a few. Then after that, we'll talk about some background on machine learning. We'll add machine learning to the VR app, which I hope you guys will find really cool. And we'll go over a few other considerations and finally wrap up with just some key takeaways. So to jump right into it, let's talk about some background on VR. It's relatively new in tech, so there's not a lot of, tooling around it. There's not a lot of hardware around it, even though it is being developed and it's starting to pick up speed. It's just super new, and there are a lot of people working to make it more accessible and easier to get started with as a developer and as a user. So these applications that are currently being made with VR include things like training med students, video games, of course, other forms of entertainment like us all eventually entering the Matrix without knowing it, or maybe we'll just willingly go. Anyways, these are the current applications or some of the things that are being done with VR. And something that's kind of helped with gaining traction in VR is that it's offered a lot of different career paths for developers. So you don't necessarily have to make a web-based app to do a VR project. And you can take the skills you have from web development and use them in VR, which opens things like using virtual reality in a browser or maybe even expanding to different fields like we'll have VR agriculture apps. I don't know. Somebody's going to make it one day and it'll be super useful and cool, but that's just another career path that we can take as developers. And as the hardware keeps improving, as Oculus makes more refined versions, as Google continues to work on whatever their fancy top secret VR tech is, when um, these hardware pieces start to get better and they give more people access to VR headsets, that's where we're going to see kind of this boom in VR. So we'll expand away from just video games and entertainment when the hardware is so cheap that you could furnish an entire school with them, or maybe you could use them for, I don't know, some other kind of training. Either way it goes, as the hardware improves, we get to do cooler stuff with the software. So that's one of the things we're waiting on for VR to really start, I guess, embedding itself more into what we do. So with that background out of the way, we're going to go into some live code and see if it works. I have confidence and hope that my code is good, which usually famous last words, right? But I'm gonna attempt to at least just walk you through what's happening with this VR app, and I'm going to go ahead and start it because we know how long it can take to start an app locally. And it didn't this time. That's fine. Let me open it in the browser just to make sure. Oh, let me open a new browser just so we have something clean for the VR world. So this one should be localhost 8080. Oh, it's loading. I'm not going to show you yet though, because you need to know how the code works first. So I'm using the A-frame library, and it's one of the more popular VR libraries in JavaScript. So as long as you know some HTML and some JavaScript, you can make a VR app literally right now. So you'll import the A-frame library like this, and just to make it easier to get started with VR, you have to have different assets in the world. You have to have a world for the assets. And if you're not super big into computer graphics and just different kinds of design, then it's really hard to make all of those things. That's a whole different coding problem. If you're familiar with something like Blender, it is beautiful for making assets for VR applications or basically any web-based thing where you need a 3D model. But I digress. To avoid having to make our own assets and environments, you can import this A-frame environment component library package thing, and it comes with a bunch of pre-made environments that you can use to give your world a base layout. And then you see here we have two custom scripts that we'll go over in a little bit, but this is the basics of what you need to import to get started. So where it gets interesting is here in the body. A-frame takes advantage of these A tags, so it's really similar to not JavaScript, to HTML, but it's been A-frameized. And the way it works is inside of your body, you have this scene component. And as you can see, the scene encompasses everything in your VR world. So that is how A-frame knows, hey, I need to make sure I'm rendering this in the browser correctly. The first thing you do inside of a scene is import your assets. So in our case, we're going to have a few images and some audio that I really would like to play, but for virtual conferences, you probably don't want to hear video game music in the background for the rest of the talk. So I just included this in here in case you want to add some audio to your VR world. You have a really easy way to. It's just the audio tag. It's nice, right? But again, I digress. We have our assets in here. They have these IDs, and we're importing them from whatever directory they're in. So we have assets. Then we have some primitives in A-frame. So this A box is literally a box. So you have an ID of wooden block, so we can target it with our JavaScript. It has a height of 3 meters because, well, the SI unit system is better. Again, I digress. It's 3 meters though, and the rotation on it is just arbitrary, but that's the X, Y, and Z axis. And we gave this one a source for what we want it to look like. So we're giving this block a wooden texture, which means we're basically imprinting this image onto this box. That's all. And we give it a position in the world, which these units are also in meters, which is wonderful, but it is 37 meters away from the origin in the positive X, 1 meter above the origin in the Y, and 37 meters behind the origin in the Z. So that's how locations and sizes and things like that work. Then here we have this attribute that gives it an animation that just happens in place on a loop. We take the property of the object that we want to move about. So in this case, we want the box to move on the y-axis. And we're going to take it from its initial position of 1 meter and raise it up to 2.2 meters. No particular reason. It was a good number at the time. But after that, we're going to say, hey, alternate directions. When this meets 2.2 meters, make sure it starts going back down to 1 meter. And this whole animation takes 2 seconds and we just continuously loop it. That's how you do some of the animations in here. And then we have our own attributes. This is where it gets fun. So we're not going to jump into that yet because we got to finish up here, but it is right after this. So now that you know how a primitive works and you've seen basically the core attributes you'll be working with, we can go ahead and finish this up. So we have a sphere and it has that metal texture from the assets up here. And we have another box. It has a different attribute on there. I want you to make sure you remember this one. It'll be important in a little bit. But we have a box, we have a stone cylinder, and then we have a plane with the instructions for the game. So when you enter the VR world, there's just this plane floating in the air telling you you need to find these 4 objects that are scattered about. So that's how we do that. It's just a plane. Inside here, this is the base A-frame entity. You can make up any of these other primitives with just this A entity tag. You just have to set all of the attributes. And then down here is where it gets kind of into the nitty-gritty of how the world works. So you need some kind of environment unless you want your users to float around in just this big open white empty space. Or you can give them a sky and a ground and some trees to run around in, or whatever else you want. So in our case, we're using the entity tag to set the environment for the world. And this is just a bunch of attributes that are being set. The reason we can do that is, if you remember earlier, we imported this package that gives us access to pre-made environments. So that's how we're working with this environment attribute. We're just setting the different values to use for that world. So we have our environment, and the last thing we need is the camera and how we're going to tell the user where they're looking on the screen. So we have another entity, we have a camera, this just a camera. You put the look controls on it, so that's how you can use the hand controls and it can pick up your head movements, or on the browser, it can pick up your keyboard movements. So we have our camera, and inside of the camera, we have this little cursor entity. This is just a little black ring in the middle of the screen that lets the user know where in the world they're looking. So it helps with targeting objects when you're trying to click on them, as you'll see pretty soon. But this is how you make up a VR world. This is it. If you know some HTML, you know a little JavaScript, and you don't mind reading through documentation, you can have this exact same app done in probably the next couple of hours. But now that you've seen the code, I can finally show you the world. Oh, see, this is that. Oh, let me click it. This is the entity I was telling you about, where we have our list. The fact that I can use the mouse to move around and look is a part of the looks control attribute on the camera. And this is in the browser. So you can port this same code over to any of the popular headsets. I think Oculus is the one that's commonly used with A-frame, but we're going to try to find something. I usually can find it pretty fast, but maybe I don't know where it is today. Oh, there's the metal sphere. You see how that little black circle helps? Because if I didn't have that, I wouldn't know which direction I was really looking in. But if we drag that over here, we found an object, and if you go back to the home base, you'll see it right here. So yeah, this is the gist of the world. You run around and you find stuff. But back in the code, I want to show you how that happened. So remember that found item attribute? That's a custom script we made so that Whenever we find one of these objects, A-frame uses this register component to interact with everything that's on the screen. So we go ahead and find the objects that we want, we set an event listener to them, and inside of the event listener, we're adding just this position. So anything that you want to happen on the object when it's found, you can set it in this add event listener. And in our case, as you find each item, it just makes a row of items that you can walk through at the end. And that is it for the VR portion of it. Everything this app does right now is just from these two files. That's all. But now we can get back into some background on machine learning. So when we add it to the app, we're not like, what is this? So we'll be using a neural network, and a neural network is just this set of algorithms or one algorithm that can be used to make predictions based on data that you've given it. So it's made up of a layer of nodes because it's supposed to represent what it's like inside of your brain. So we know we have neurons that fire off. In neural networks, there are different nodes that send different information further through the network. And this is what a typical node looks like. So you have some inputs. These are usually referred to as features, and they reflect what is important to the prediction you're trying to make. So in our case, we're going to try and predict where we should place objects to increase the likelihood of a user finishing the game. So that might mean we want to look at how many steps a user's taken. We want to look at if they found an object or not yet. And then you can use the weights to determine how much that affects the overall prediction. So you're not just feeding it data and it spits out a prediction, you're feeding it data that specifically gets tuned to show the effect that your inputs actually have on your output. Then in here, we just do a bunch of cool math and we get our prediction. But usually there's more than one layer of nodes, and when that happens, you're already doing deep learning. Deep learning just means you have more than one of these nodes in a neural network. That is all. So hopefully that gives a little bit more perspective on what's happening in the machine learning world. It's not as terrifying as a lot of people make it out to be. Yes, there's a lot of math, but when you're a developer and you're not developing algorithms, you can just use the tools in the libraries to do all the math for you. As long as you get the basic idea of what's happening, that's all you need. But we're getting to talk about my personal favorite JavaScript machine learning library, Brain.js. So there are a lot of reasons I chose this over TensorFlow, a lot of reasons, but one of them is because it's easier to use. If you know how to work with objects, arrays, and arrays of objects, you can do machine learning with Brain.js. You don't need to learn what a tensor is. It doesn't hurt to know about dimensionality because you need to sometimes, but there's just so much it strips out from the math heavy part of machine learning to let you focus on implementation. So you don't need to know what stochastic systems are. You don't need to worry about Bayesian distributions and yeah, flashbacks to math stuff, but you don't have to worry about all of that. You can just jump into the library with whatever idea you're trying to test out and test it. And then the tutorials are super easy to follow. They're straight to the point. And by the time you finish them, you know how to use the library. You might not know exactly what is happening in the machine learning portion, but you know how to apply it, if that makes sense. So with machine learning projects, there are a few things you have to consider. especially when you're choosing the features that you're going to use for the inputs for your neural network. So the first thing you should think about, what is going to add the most value for a user? We usually get caught up in how cool certain tech things are, or this new shiny tool, or whatever obscure tech thing we've heard of. We get caught up in that and forget about the user. So when you're choosing features, you probably already want to know what you're trying to predict. That's going to help you figure out what's adding the most value for a user. And then how are you going to get the information you need to train that model? So are you going to go buy data? Are you going to collect data from users somehow? Are you going to start with just some dummy data from a lab? You need to know where you're getting this information from. And again, what are you trying to predict with all of this data and information you have? There are companies that have literal terabytes of data, hundreds of terabytes of data, and they're like, yes, we're going to do machine learning with this. But they have no idea what they're trying to find out. And that takes away from the whole purpose of machine learning. What are you trying to find out with that data? And this is one of my favorite questions. If you make this update, if you choose this feature, will the user care? Will that feature choice you made actually influence the prediction in a way the user will care? So, as much as we like to do cool new stuff, it's important that the people we're making these tools and apps for care about the changes. And now here's time for another moment of truth to see if the code will run. So we've already covered how to make this. The thing that I want to talk about next is the actual Brain.js code. So we have this little node server set up. We're importing the Brain.js library and just some of the other libraries that go with a backend Node app, like Body Parser, Express, and Chorus. So we go ahead and set up the app. We're using these different methods to handle our data and interactions with the front end. And then we get to the really interesting part. So I do have this code in a GitHub repo, and I'll post a link to it in the Thunderplay Slack after this talk in case you want to look at it. It's got some comments in here so you can read around. But the first thing we're going to do for the machine learning model is set up our training data. And the way Brain.js works, I mentioned it just basically works with arrays of objects. So our training data, we've decided the features we're going to use to predict where we should place objects next. We've decided we're going to take the position of the user, so the X, Y, and Z position of where they currently are in the world. We're going to assign a value based on whether they found an item or not, and we're going to look at how many virtual reality steps they've taken to maybe determine if they've been wandering around for a while and they're a little lost. So this is what our training data input looks like, our training input data. These are the features that we think will predict whether or not a user will finish the game. So to make that prediction with something like a neural network, you have to have both the initial data, and that includes what your predicted values would be. This is called a supervised machine learning problem because you have to train the model with input data that's associated with output data that's already been proven to be correct. And so basically what that means is we have input data, we have predicted data, and we're just trying to figure out how those two match up mathematically. So think of, what was it? Y equals AX plus B, something about slopes and whatnot. But that's pretty much what we're doing. We're solving for the function instead of the values. But you've seen what the input data looks like. We have quite a few array objects. Now we're going to look at what the initial prediction data or the initial output data looks like. It's also just an array of objects, but it predicts whether or not a user will finish the game based on all of these features. So that's what we're trying to predict here, is whether or not they'll finish the game. And based on whatever values are up here, they will finish or they won't finish. It's just another array of objects. So now that you know what the input data looks like, you've seen what the output data looks like, we're going to combine all of this into one array of objects where we have our input data as a property and we have our output data as a property. So all that happened here, it's like I said, we made an object with our training data. And we did that because that is how Brain creates neural networks, which we're doing right here. So this one line of code makes an entire neural network with 3 hidden layers. And the hidden layers represent how many nodes we have in this neural network. But we just call this new class, we give it the parameters it needs, and it gives us a neural network. And then we want to go ahead and train this network. I'm going to save this and hope that a space doesn't break the code, because we know that happens sometimes. But we go ahead and train the neural network that we just made with this object, and we're giving it that training set data that we made up here. And that's it. We have a trained neural network now. It's ready to make predictions, and we can use it in our VR world. But a lot of times with machine learning projects, pretty much every time with machine learning projects, you want to take note of the stats on the training process. So you want to make sure that you have a low error. You want to make sure that it doesn't take too long to train. I've tried training some machine learning models that have bricked computers, not crashed them, but blue screen of death because I didn't have the right resources. So you really want to make sure that your model is performant before you run too big of a training thing. So a lot of times we'll run like a test training, and then we'll run the real one with all of the data once we see how performance is, how error rates are, and things like that. But just to get an idea of how we use this model, after it's trained, we go ahead and log a little bit to the console. And this net.run, that is how you get a predicted value with new input data based on your model. So in this case, we're passing in a new object that has a user's XYZ position. They haven't found an item, and they've taken over 3,000 VR steps. So the likelihood of them finishing the game is probably really, really low. But now that we've gotten that out of the way, we've trained our model, we've run it, we've checked the stats on it. So we'll go ahead and just make an API endpoint that the front end can post to and take advantage of this model. So what we're doing here is we're just checking out the positions, the steps, and whether they found an item, and that's passed to us from the front end in the request. Then we're going to get that value, and we're just making something up here. So we're going to use the model. This is the part that I'm attempting to live code. We're going to make a new variable and call it prediction. Yeah, prediction, because I'm super creative. So we'll call it prediction, and we'll take our model and do .NET run. And then I'm just going to copy and paste this in and give it the appropriate properties. So that'll be X, Y, and I could leave it like that, but I like to explicitly define object properties because sometimes later on it can, I don't know, it throws me off occasionally. But anyways, so we're giving this to our neural network, and we're going to take the prediction, which is whether or not they will finish the game. And instead of item found, which was just a placeholder, we're going to put that prediction. So we're going to say if our prediction that they will finish the game is greater than 50%, we're going to move the objects further away from them. That way, it makes them stay in the game longer and they explore the world more. But if they're having a hard time and they're not likely to finish the game, we're going to move objects closer to them so that they'll find something and it'll keep them engaged and they'll keep playing the game and exploring the world. So we take that prediction, we pass these new positions back, and that is how we relocate the objects in the world using machine learning. This is how you make a super custom game to any individual. It's based completely on their movements, their actions, and how they interact with the world. And of course, this applies to way more than just games. We could use this. I don't know why I want to do VR in agriculture, but maybe one day. But anyways, so we can take a user's real time actions and make predictions to update things real time. We don't have to retrain the model. We don't have to handle a bunch of like back end requests unless you want to. But this is the entire machine learning model, the training, and the implementation of machine learning in a VR app. Woo! But yeah, we go ahead and send our status, we send the data back, and start up the server. So let me see if I do a split terminal and just run this backend. So node server.js. Let's see how training did. So our error rate isn't the best. It's a 25% error rate. So this is an example of when you would probably want to get more data or you'd want to look at your features to see if you can do any grooming there. But you generally don't want a 25% error margin. You want to make sure that the inputs you give your model accurately predict that output, or else you end up with not what you wanted. And you see, it took 20,000 iterations, but that happened really fast because look at the data we're using. It's not that big. Data for machine learning projects can take up gigabytes. So this is nothing for it. But it did predict a likelihood of about 51% finishing for this data we inputted. So this is just an example of what it looks like when you get your predicted value. So I'll go ahead and do that. And I want to show you where this works. So there is no particular reason I put this attribute on this element other than it's just the one that I picked first. But what this does is whenever a user finds this blue box, it's going to call this. So we're going to find all of the objects in the world. We're going to get the position from the user, and that includes like the steps, and need to go ahead and include some other stuff, but that's in a different file. So we'll go ahead and send the position back, and once we get the response, we set the positions for the objects to whatever that new position is based on whether a user will finish or not. So this send user data, it's coming from this user model file, and that's why we're not setting the steps or item found in the cursor listener, because this is how I set it up for the demo. But we're using Axios to go ahead and make the post request. We have the user's real positioning. We made up something for some steps. And just for the sake of things, we set this attribute to true. But the way it works, we go ahead and make that call to that endpoint we set up, and it's going to return our data. And that's how we get these. So that is how we implement machine learning in a VR app to make stuff more interesting, more custom for a user. Woo! So back here, we can go ahead and start winding down. A few other things you should consider when you're working with VR or you're making some kind of machine learning model is the overall user experience. What kind of impact are your decisions having on the experience you're trying to create? So every user has different expectations for how apps should work, and you have expectations for how users should interact with it. So when you're making a VR app, consider how they're moving around the world, how they'll interact with things. And whenever you're working on a machine learning project, make sure you're using data ethically. This is something that is a very gray area in tech sometimes, is the ethical use of data. So yes, ads are very lucrative at the moment, but is that really something you want to steal data from users' VR worlds and sell to people? Just keep your data. Everybody will appreciate it a little bit more. And then I want to go ahead and break this common misconception. There is no best algorithm in machine learning. It's not one. It depends on what you're trying to predict. It depends on the data you have. It depends on the resources you have. It depends on maybe even the team you're working with. So there is no one machine learning algorithm that's the best. It super depends on what you have to work with. And if you're interested in more machine learning things, definitely get into Python because JavaScript is great. I love JavaScript and all of its wonky jankiness, but Python has um, way more packages and libraries for different machine learning applications. They have some really specific ones like BERT, which is how you train a natural language processing model. So if you want to get more into machine learning, definitely look into the Python packages. So now, just about to wrap it up. A few things I hope you remember from this is that it's so important to combine multiple areas of tech. We usually stay so siloed that web developers are different from, I don't know, security people who are different from DevOps people, even though we kind of all use really, really similar tools. Even if the underlying languages or tech is different, or even the way applications are created, we all use these different areas. So it's okay. Just mush them together and see what happens. And please remember that ethics around data is important, but ethics in general, especially in tech, they're so important because if we don't pay attention to those really small things, it snowballs to become something giant like Skynet or some other entity that's just going to take us all out one day because this is 2020. And try new stuff. So I picked up the A-frame library one day last year and just made little apps and got some projects with it. So don't be afraid to try new things. There's also a React version of a VR implementation. I think it's called React 360. I'm not sure if that repo is still being actively maintained though. And if you take the time to learn something that is interesting to you and it solves a problem you have, you win. You did it. This is what we want. We want to combine things that have useful outcomes, even if it's something small for just around the house. So that's all I have to share with you today. And if you have any questions, definitely around. Be checking the Thunder Plane Slack. And of course, please follow me on Twitter at Flipped Coding.